Picture this. You finish your bottle of water and you toss it in the recycling bin. And you feel good about it. You've done your part. But what if I told you that less than 10% of those plastic bottles are actually recycled? The rest, they just end up in the landfill or in our oceans, harming our environment. The plastic I'm talking about is called PET plastic, and it's found everywhere. Plastic bottles, food packaging, and even in our clothing. We produce millions of tons of it every year, and it doesn't just disappear. Traditional recycling methods are not enough. Mechanical recycling produces lower quality plastic. Chemical recycling is expensive and it still just produces more plastic. So instead of simply recycling, what if we could upgrade it? What if we could turn it into something more useful like renewable fuel? That's the question that drives my research. I work with an organism that you probably know, baker's yeast. It's the same yeast that we use to make beer and bread. At first glance, yeast and plastic don't seem to go together, but yeast is actually one of the most powerful tools in biotechnology. It's easy to engineer, it grows fast, and it's already used at massive industrial scales. There's just one problem. Yeast doesn't know how to eat plastic. So I'm teaching it. When we break down PET plastic, one of its main components is a molecule called terephthalic acid, or TPA. Normally, yeast can't use TPA, but there are certain soil bacteria that can. So I borrowed the genes from one of these bacteria and I introduced them into yeast. This way, the yeast can use the TPA and convert it into a high-value chemical called PCA. And PCA is very useful. It can be turned into biofuels like bioethanol, but also pharmaceuticals, antioxidants, biodegradable plastics. In other words, instead of turning plastic waste into lower quality plastic, we can turn it into high-value sustainable products. Imagine fermentation tanks like those used in breweries, helping solve the plastic crisis. My goal is to build a yeast platform that can convert plastic waste into high-value chemicals like PCA. This research could help tackle two global challenges at once: reducing plastic waste pollution and supporting our transition to renewable fuels, all with the help of an organism that we trusted for thousands of years. So maybe the future of plastic recycling doesn't look like a recycling plant at all. I think it looks more like a brewery.